everyone, welcome back to my channel and another new video. And in this video we're continuing the complete data structures algorithms interview preparation bootcamp. If you don't already know, we're doing the complete bootcamp for you to clear your interviews, learn about data structures algorithms. So make sure you check out all the links in the description below of other topics we have covered already. And in this video we're going to learn about a very important sorting algorithm, count sort. So we've recently learned about hash maps and all sorts of things. And now we're going to learn about count sort. What is count sort, the advantages, when to use it, how to use it. We've covered previous sorting algorithms as well. There's a complete playlist on that. But yeah, the code for this video can be found in the description below. If you have any questions or comments, leave those in the description in the comment section below. Any questions, happy to answer those. And let's get started. So count sort. Count sort is very simple. It's, as the name suggests, count sort. You count stuff, but how does it work, what it is? So it is a non-comparison based sorting. So you know how you compare elements in like bubble sort and other sorting algorithms. Here you don't compare element. Comparison sorting algorithm, good for smaller numbers. Okay, good for smaller numbers. So when the input value is like small and yeah, the numbers have to be small. And the basic idea is that, let's take a question. If I take a question over here, the basic idea of count sort, it's very simple. Let's say you want to sort an array and the array is something like this. Again, remember, small numbers only. Okay, so let's say array is 3, 4, 1, 3, 2, 5, 2. These are the indices. Okay, so what I'm going to do is I'm going to be like, find the, first of all, what I'm going to do is I'm going to find the largest number in this array. So the largest number is equal to 5. Largest number, step number 1. Step number 2 is I'm going to create an array of size largest plus 1, so of size 6. Okay, largest plus 1. Now what I'm going to do is I'm going to traverse the original array and I'm going to store the number of times that number is coming. Because 5 was the largest number in the array, I know that all the other numbers in the array have a numbered value index in the new array. Do you understand? For example, let me do it in a more nicer way so that you understand. Let's say we do 8. Index number 7, largest is 8. So largest plus 1, size 9. So I will create an array of size 9. One, 2, 3, 4, 5, 6, 7, 8. So I created an array of size 9. I know since the largest element in the original array was 8, all the other elements that are remaining in the array, they will have an index in the new array. For example, if I talk about let's start from the first one. I talk about 3. So I will create a frequency array. So 3, index 3 is over here. Yes, 3 is coming in this array one time. Then next 4. 4 is coming in the original array one time. 1 is coming in the original array one time. 3 is coming another time. So 1 plus 1, 2. 3 is coming twice. 2 is coming once. 5 is coming once. 2 is coming again. So this will be 2. 8 is coming once. 8 is coming once. Rest 0. So you can see I've created a frequency array. Frequency array where the index number is equal to element number in original array. So you can see in the original array 0 is coming 0 times, 1 is coming once, 2 is coming twice, 3 is coming twice, 4 is coming once, 5 is coming once, 6 is coming 0 times, 7 is coming 0 times, 8 is coming once. Now what you're going to do is traverse the frequency array. Okay, I will traverse the frequency array. I will create a new array of the size, or I'll just replace the original array. Okay, I will say if the value of the index is greater than 0, it means that that index is in my original array. And now since the indices are already in sorted order, I will take one by one. So for example, 0 is coming 0 times, I will not take it. 1 is coming once, so I will add 1 over here. 2 is coming twice, I will add 2 over here. 3 is coming twice, I will add 3 2 times over here. 4 is coming once, I will add 4. 5 is coming once, I will add 5. 8 is coming once, I will add 8. Array sorted. Easy. There is nothing to explain over here. It's very simple. Count the number of times it is coming. So what is going to be time complexity? Think about it. You tell me. Searching the original array of size n. This is, let's say, size m. Searching the original array takes n time, plus searching this array takes m time. O of n plus m. Similarly, the space complexity as well, O of n plus m. Okay, if we're taking about the output array. But if you're just talking about, let's say I am making changes in the original array, I'm not creating a new array for the output, then space complexity is O of m. Okay, because this is extra array I'm creating, the frequency table. That's count sort. Easy. Now one thing you can do is, instead of array, hash map. Instead of an array, a hash map. So you can have, for example, here I can say 3 is coming once, 4 is coming once, 1 is coming once, 3 is again coming one more time, so the value increased to 2, 2 is coming once, 5 is coming once, 2 again, and then 8 is coming once. Thing you have to note over here is that in hash map, I told you in the previous lectures, items are not in sorted order. So this key over here, these might not be in sorted order. So how are we going to get the elements? In the previous lecture, in the previous example, we were just, because the indices are already in sorted order, I am just taking indices 0, 1, 2, 3, 4, 5, 6, 7. Here also you can do the same thing. Since we're talking about numbers, so maximum I know is equal to 8. I can start searching from I is equal to 0 till 8. So map dot get I. It will search for 0. Does 0 exist? No, it doesn't. 1 exists. Yes, 1 exists. Its value is 1. Okay, new array 1. 2 exists. Yes, its value is 2. Added 2 times. 3 exists. Yes, value is 2. Added 2 times. 4 exists. Yes. 5 exists. Yes. 6 exists. No. 7 exists. No. 8 exists. Yes. Okay. Easy. Space complexity is what? The total number of, it's also linear, like total number of unique elements. So it's also linear, but worst case it will be O of m again. And the time complexity remains n plus m only. Very easy. So we can code both the solutions, both are fine, but ideally the best solution is using array. Okay, because it's much more simpler. or if you want to use, you can try tree map because it stores in sorted order. But let's code it. Okay, so the code link can be found in the description below. I'm going to create count sort. Easy. Okay, so generally if I talk about like, what are the advantages of count sort, why would you want to use it? So it's very fast based, like when you compare it to comparison based sorting algorithms for very small numbers. And it's also a stable algorithm. We have already covered stable algorithms in the sorting lecture series. But the thing is that when I talk about the disadvantages, so first of all, it doesn't work very well for decimal values, and it doesn't work very well for large numbers. For large numbers, we'll look at radix sort in the next video, which is also very important. And it's also taking extra space and not in place sorting algorithm. So that's also one of the advantages, but I told you the disadvantages, but I told you the advantages also. Okay, so count sort, very simple. I am going to create a function. Okay, if array is equal to null or array dot length is less than equal to 1, I will just say nothing to do. You can just return. That's fine. But what is the first step that we need to do in count sort? I have to find the largest element. Largest is equal to, let's say, or I can say max is equal to array of 0 num in array. If num is greater than max, max is equal to num. Just finding the largest number in the array, not a problem. We are way past that. Okay, now I'm going to create a count array. The size of that will be equal to max plus 1. So that I can get the indices, right? The same thing we did before. Now I will traverse over the original array. So I will say index is equal to 0. No, I will traverse over the original array. So for every number in original array, count array's index, the index is equal to that number itself, just add it. This will create the frequency array. Okay, because it will be like 3. So count array 3 plus 1, 1. 4, index number 4, 1. 1, index number 1, 1. 3, index number 3 plus 1, so 2. So it will create this frequency array. Now I will run through this frequency array. I is equal to 0, I is less than equal to maximum value that I had, and I plus plus. What I'm going to do now is that whenever I find an element that has a non-zero number, it means that many times it will come. So while count array of I is greater than 0, I will add it in my original array. Array of that, like I'm starting to add from 0th index. That's why I've taken this another variable index number 0. So it will traverse the original array from 0. So that index is equal to I and index plus plus. Okay, and I will say count of array of I minus minus, and that is it. Simple. 0, it will be like, okay, is count array of 0 greater than 0? No, it's not. Okay, move forward. Count array of 1 is 1, which is greater than 0. So just index number 0, it will add 1. Then it will do index plus plus. So now it will be here. And here it will do index minus minus. So this will again become 0. Okay, plus plus minus minus. Very simple. You can run this. 3, 5, 10, 6, 3, 10, 9, 20, 9, 2, 4, 9, 7. System.out.println arr, I can say okay, and here it will be I'm just printing the array is to string, count sort should be fine. We did the dry run. It's a very simple algorithm. Run this, sorted 2, 3, 4, 6, 7, 9, 9, 10. Easy, cool. Okay, now what we can do is we can also create count sort now using hash maps. So let's see how we'll do that. Public static void count sort hash int array. Same thing I will do. Make sure when you're copy pasting, you copy paste correctly. Okay. And I'm going to have to find the maximum item and the minimum as well, so that I can create this map. So what we're going to do is that int max is equal to, actually you can also do a shortcut, arrays.stream. In the array I can say dot max get as int. This is actually a shortcut to get the maximum item. Similarly you can get minimum item. Please use no object-oriented programming, the frameworks and stuff, all the collections and everything. Okay, map integer comma integer. I can say count map is equal to new hash map. Interface and the class. How we are making objects should be clear in object-oriented programming playlist. For every number in array, I can say count map that number, whatever the value is, plus 1, but you have to get a count map dot, sorry, I have to put inside this map where this number is. What do I have to put? The original value that is already here, count map dot get or default. So for example, if there's no value, I will take 0, original value or 0 plus 1. Easy. Then I will build my same thing I'll do. Take index equal to 0. Int I is equal to what? I'll start from minimum to maximum, just to make it a little bit more efficient. For example, here I'm not starting from 0, I'll start from 1. Okay. I'll say int count is equal to count map dot again get or default for that I, or get 0 if it does not exist. And then I can just say for int j is equal to 0, j is less than count, and j plus plus for every like element in the array. I'm gonna say like number of times the count is appearing. So it's say 1 is appearing once, so the loop will run once. The j loop, 2 is coming twice, so the j loop will run 2 times. And I will say array of index is equal to I index plus plus. That's it. Easy. But I'd recommend do the integer way, the array way. Okay, we can try to run this. It'll give the same answer. 2, 3, 4, 6, 7, 9, 9, 10. Easy. Yeah, that's pretty much about it. If you have any questions, leave those in the comment section below. All the code links and everything, assignments, previous lecture videos, everything can be found in the description below if you want to support the work we do. So make sure you like, share, and subscribe and comment. And yeah, I'll see you in the next one. Have a great day.